right, now we're going to do the second part of this assignment. And the first two are just giving us a graph. Want to make sure that we're clear as to how to identify. The first one says, what's the limit of this function as x approaches 0? And so what we can see is that that equals 1. That's what the function looks like it equals. And then as it approaches -1, we can see that it equals 3. Now what it wanted us to do is to try to write a simpler function and then maybe see that happening through there. So if you pull an x out of both of these, you're going to have x times -2x plus 1 over x, and these x's can cancel. And so we end up with -2x plus 1. Now, if I were to put 0 in for that, 0 plus 1 equals 1. If I put -1 into there, -2 times -1 is 2, 2 plus 1 is 3. All right? So being able to write it in that simpler form is another way that we could kind of solve it if we didn't have the graph. Same thing here. I have a graph of this, so what's going on at +1? It sure looks like it equals 2. What's going on at -1? It sure looks like it equals 0. Okay? Now, if I wanted a simpler thing, I could pull an x out of this. I'd have x squared minus 1. I could factor that into x plus 1, x minus 1, and let the x minus 1's cancel. I end up with x times x plus 1, okay? Which I can leave or I can distribute, doesn't matter. If I put 1 in there, I get 1 times 2, which is 2. If I put -1 in there, I get -1 times 0, which is 0. So those are a couple of ways that we can do that. So off of a graph, hopefully you feel really good about understanding the difference between a limit and a function value and how they sometimes are the same, different, but know the difference between them. And now we're starting to look at some of this algebra. So again, the first thing you should always do is plug it in. If you put 5 in here, you're going to get 0 over 0. And 0 over 0 tells us nothing. Okay? It's what we call an indeterminate form. And in next chapter, we're going to show you a way to do this real easy using something called derivatives. But we don't know those yet, so the only thing that we would have at our disposal would be to try to simplify. So if you broke this down, x plus 5, x minus 5, let the x minus 5's cancel, we're going to get 1 over x plus 5. So now I've got the limit as x approaches 5 of this. Try it again, throw the 5 in, and we'll get 1/10 for our answer. Okay? So right now, that's the only way we would know how to do it, but next chapter we're going to find a simpler way. All right, same thing here. If I throw -3 in, I'm going to get 0 over 0. Who knows what that means? Let's do a little bit of work. So this is x plus 3, x minus 2 over x plus 3, x minus 3. X plus 3's cancel. I get x minus 2 over x minus 3. All right, so let's try it again. If I put -3 into the top, I'm going to get -5. Put it in the bottom, I get -6. A positive 5/6 is what we end up with. So this one here, when we put the 12 in, we're going to end up with, I'm sorry, we're putting 2 in, forgive me. When we put that, or 0 in, I think, let me just, give me 1 second here. Yeah, that's a 5. I can't read my own writing. Apologize. So we're putting 0 in. And when we put 0 in, we're going to get 0 over 0, which is, again, who knows. So on this type of problem, there's a little bit more work involved. You will never have to do this on an AP test, so don't worry. But the work that we do is we multiply top and bottom by what we call a conjugate. So we look at this and we say, instead of minus, what if we had changed that to plus? All right? What happened, and we're going to do top and bottom by the same thing, so we keep it the same. Okay. Now, if I do the top, this times this is going to give me just what was underneath it, right? Anytime you take square root times itself, you get that. Okay. When you do the outside, it's going to be something ugly, but what's nice is that when you do the inside, it cancels. Right? It's the same ugly thing, just one's positive, one's negative, so that's going to cancel out. The last thing times the last thing, negative times positive is a negative. Square root of 5 times square root of 5 is 5. Okay? Over. Now the bottom, we're going to leave it. We're not going to try to get cute here and try to multiply things out. We're going to leave it like that. And the reason for that is because now you can see that those will cancel there. and leave me with just x now on the top, and that x will cancel here. So we end up with this now. And we are expecting something nice like that in this problem. If it doesn't work out like that, then yeah, we've probably done something wrong, right? So now I'll put the 0 in. I get 1 over square root of 5 plus square root of 5, which is 2 square roots of 5. And that's our limit. Okay. Again, these are definitely on the harder end, and the good news is you will not have to do them on a quiz or a test, or on an AP test, so no worries there. All right, right here, multiply by the conjugate. Multiply by the conjugate. All right, on the top I'll have square root times square root, which give me x plus 5. The outside and inside will cancel each other. I'll be left with negative 3 times 3, which is a negative 9. Okay, over x minus 4 times this. Again, we're anticipating something nice is about to happen. And that nice thing is right here. If I were to take 5 minus 9, I'll get x minus 4. That cancels with that x minus 4. And now I have 1 over x plus 5 plus 3. The limit as x approaches 4. So let's go ahead and do that. If I put 4 in there, 4 plus 5, 9. Square root of 9 is 3. 3 plus 3 is 6. Okay. So a little bit more algebra, a little more of a challenge to know what's going on here. But again, the good news is we're going to show you an easier way to get all of these answers when the time comes in next chapter, okay?